I'm Arun Serafin, the Executive Director of the Emerging Technologies Institute at the National Defense Industrial Association. I want to thank all attendees for your support of NDIA and ETI and for joining us at today's webinar. This webinar is part of our Tech 101 series, where we present complex technological concepts as introductory webinars with a focus on their national security implications. Today's 101 will be covering extended reality. Extended reality is an umbrella term that encompasses augmented reality, virtual reality, and mixed reality, blending the physical and digital worlds through immersive experiences. Extended reality technology allows its users to do things like interact with virtual environments or overlay digital elements onto the real world, transforming how we engage with traditional content and changing the way we can learn, collaborate, or create. As extended reality continues to evolve, it might revolutionize the future of human interaction and technology integration. And more importantly, it may play a role in shaping how the Department of Defense can use it towards executing all kinds of different national security missions. We'll dive into these issues and your questions during today's webinar. Some administrative remarks before we get started. One, all attendee lines are muted. Second, if you have a question during the webinar, you can submit your question in the question box in the webinar panel on the right side of your screen. You can submit questions during the presentation, please do. We'll do our best to get through all the questions during the Q&A portion at the end of the session. We're recording today's webinar for members unable to attend and for any member who wants to watch it at a later time. Within the next few days, we'll post the slides and the recording to our website and our YouTube channel. Now let me introduce our speaker for today. Our guest today to teach us more about extended reality is Gagner Congdon. He's a program manager at SAIC, where he oversees development of mixed reality training and education platforms. Gardner established SAIC's Big Timber Interactive Studio, where the focus is on designing and developing highly engaging applications using technologies and methods drawn from both the defense and the commercial entertainment video game industries. He's previously managed development teams working on diverse topics, including wheeled rotary fixed-wing vehicle operation, first aid instruction, and weapon and flight training. Prior to joining SAIC, he worked in serious games development, and he established and ran Zombie Studios' Serious Games division. He's also a member of the International Game Developers Association. Gardner, thank you for sharing your expertise with us. So at this time, I'm going to turn it over to you.
Hey, thanks so much, Arun. Happy to be here this afternoon. Let me share my screen and we'll get right into this. Okay, hopefully you all can see that. So as Arun said, we're going to be talking about extended reality today, and I just want to thank everybody for showing up and showing an interest in this topic that has really been a love of mine for a number of years now. A little background about myself. I began my career in healthcare and got very quickly involved in the startup scene in Seattle in the 1990s. Published my first virtual reality game in 1995 and actually brought that to Helsinki, Finland, and demonstrated it. Really, since that time, I've been focused on gamification and the use of, as Arun said earlier, the use of video game technologies and methodologies for things like simulation and training and education. About 5-6 years ago, closer to 10 years ago now, time flies, founded Big Timber Interactive within SAIC, which is a studio within the company just focused on that type of development. And since that time, we've shipped dozens of simulation, training, and education applications, and predominantly for Department of Defense customers, but not strictly. And the photo is just myself and my development team in the Seattle studio. So for the agenda, we're going to talk about some definitions of these technologies, a fair amount of history, which I think is important to understand how the technology evolved over the years. We'll go into some current examples of how the technologies are being used, and we'll talk through some of the challenges that face both the technologies and the markets and the use of those technologies. And I'll give you my opinion on a bit of what I see as the future in the space. We are not going to do a deep dive on how these technologies work. I think for a 101, I think you're probably better served understanding just what the technologies are and how they're used. And if you're interested, certainly in what makes these devices tick and how they actually function, that's probably better left for maybe a 200 level course. So we're going to start off with some definitions and really want to preface this with a bit of a disclaimer. I'm going to use my definitions, which I think are sort of convenient and what I've come to use over the last 20 or so years of using these technologies. They may not match exactly what's referenced in every single website. And part of the reason for that is that the technologies continue to evolve, right? And as the technologies and the devices evolve, the definitions get blurred or they morph over time. So if my definitions don't match exactly what you were expecting, take that with a grain of salt. We're going to start talking first about virtual reality. So I think this is probably the technology that people have been familiar with for the longest amount of time and perhaps what they're most comfortable with. But virtual reality is really it's the use of computer modeling and simulation that enables interaction with an artificial three-dimensional environment. And so, what you'll often imagine when you think about virtual reality is someone wearing a headset, like this gentleman in this photo here. He's got a headset on, he's got a couple of devices in his hands. And in the image below, you'll see a portion of what he would see through those goggles, which is obviously a three-dimensional environment, including his hand. And very often in VR, you'll have these controllers that sort of work as your hands that enable you to interact with the technologies. I'll make a quick note that virtual reality is not really dependent on wearing a headset. You can certainly accomplish VR in many different ways, including we for one program actually replaced all of the outward-facing windows in a vehicle with LCD screens, and that provided you your view into the virtual world. So it was a very immersive VR experience. And what VR is particularly good for, excuse me, is spatial understanding, right? So if I need to understand how to get around Rome, Italy, and I want to understand that without having to physically go there, one way to do that is to navigate through a virtual reality environment of Rome and see what that environment looks like. And the great thing about VR is that you can scale that really well. So you can think about gaining better understanding of a city or a town or the inside of a house or the inside of a human body or the inside of a molecule or an atom, right? So that differs a bit from augmented reality, and that's the next technology that we'll talk a little bit about. So augmented reality is really an experience that combines the real world and some computer-generated models. Typically, you would use a headset for this, but you can certainly accomplish that by holding a tablet up in front of you or holding a smartphone up in front of you and doing it that way. The example, the video that's playing, you can see some computer-generated images that seem to be present in someone's living room here. Unfortunately, the video that I grabbed doesn't perhaps show off the best use, in my opinion, of virtual reality, which would be to overlay data onto real world environments. And so, from the video that's playing, perhaps being able to, look at the plant that's off in the left and have some data about when it was last fed or watered, being able to see the outdoor temperature, in a different environment, maybe being able to walk up and look at some hoses on a piece of equipment and know the last time that they were maintained or what pressure perhaps the fluids in them were operating at. And then the last term in kind of this umbrella that we'll talk about is mixed reality. And really, this is more sort of a merging of the real and the computer-generated environments. So in the upper right photo, you'll see a gentleman sitting in sort of a mocked up cockpit that has some controls and some multifunction displays in it. He's also wearing what looks like a VR headset. And the lower photo is giving you a piece of what his field of view is. And so if you look, you can see, sort of the cockpit is drawn in VR, and obviously everything outside the cockpit is drawn in VR. So that landscape that's down below and that water is all, a real-time virtual environment. And then in front of the user, these multifunction displays and these switches, these are actually video pass-through using the headset. So that user can see his or her hands, they can reach out and touch those real switches and controls. And in my mind, the ideal use case for mixed reality is really where you want to drive that spatial understanding and muscle memory with, perhaps with operational controls, but to see the effects of those things in a virtual environment, and particularly a high consequence environment. And that's a subject that we're going to hit on probably several times today, is this idea of high consequence environments. And, really all I mean by that are environments where the user in a real environment might face some physical danger, might even be at risk of dying should they do something wrong. We want to train people to operate in those environments without any risk to them physically. So flying an airplane, flying a helicopter, perhaps shooting a weapon or engaging enemies that also have weapons would be good examples of those high consequence environments. But they don't have to necessarily just be, defense type scenarios. This could be, an electrician working on a live transformer. So we're going to talk a little bit about some history now, and the idea isn't to bore you all with a long history lesson here, but rather to just understand that these concepts have been around for a long time, and they've actually evolved quite a bit. And the first time that we really see anything that sort of resembles virtual reality goes back, you may be amazed, is to 1935. So Pygmalion Spectacles was a novel written by Stanley Weinbaum, in which the protagonist meets a professor who had invented these goggles that when you put them on, you can see into a fictional environment, and you can in real time interact with these fictional characters, which is like just kind of mind-blowing to me that there was science fiction in 1935 that so closely mimics what we have today. So I'm just going to kind of go through and give the highlights of the rest of these. So 1956, mid 50s, early into 1960, there was this thing called the Sensorama that was a virtual reality machine that you could put up to 4 people at a time into, and there were multiple technologies. So it was like real-time video, full color, but it also had things like vibrations and smells and atmospheric effects like wind. It was a very immersive environment. And also kind of telling for where things went in the future. Early 60s also, HeadSight was kind of an example of the first motion tracking head-mounted display. And this was actually used to control a remote camera, which was really kind of a fascinating use case. So the idea was you could have a camera in a hazardous area that's controlled by the position and location and orientation of the camera, all controlled by a head-mounted display for the user, so that they could look around and perhaps inspect an environment remotely. And then in the mid-60s, Tom Permess comes onto the scene, and 66 he creates this first flight simulator for the U.S. Air Force, and it's significant, not necessarily because it wasn't virtual reality, but really this leads to a lot of further funding for flight sim and ultimately virtual reality research and development. And we're actually going to talk more about Tom Furness in a couple of slides here. But by late 68, there was the sword of Damocles from Ivan Sutherland and Bob Spruill. And this was really the first kind of operational augmented reality head-mounted display. It could really only do wireframe models. It was just too big and heavy to be worn, but a significant step forward in the development of these these technologies. And so in 72, you've got General Electric building a flight sim that's got 180-degree field of view. And so these things are becoming kind of higher fidelity and more immersive. And in 75, I always find it interesting when artists take new technologies and interpret what they think are going to be made of them or how they're going to be used. And in 75, Myron Kruger creates this thing called Video Place, and it's the first interactive VR platform, and it used computer graphics and projectors and also like position sensing technology. So users could see their computer generated silhouettes imitating their own movements as well as the movements of others. And that was really kind of cool if you think about where things have gone in the last few years with more things like telepresence and virtual meetings and things. And then in the mid 80s, you've got Jerome Lanier and Tom Zimmerman at VPL Research. And this was exciting because this company really was the first to offer, VR gloves and goggles and things to the consumer space. And they had like a range of VR equipment, including a data glove and something called an iPhone, an EYE phone was a head-mounted display. A few more examples, and I promise I'm not going to focus too heavily on this, but this is where things start to change. So like in the late 80s into the mid 90s, there was sort of this little explosion of VR devices and new opportunities, and very heavily sort of entertainment market focused, right? Mattel, Sega, Nintendo, all getting into the game, virtual IO, and all of these things were consumer aimed devices, and they were available commercially, but none of them really had terrific graphics. The cost was, high, certainly for the day. The support was pretty terrible, kind of across the board, and comfort wasn't very good. And this is, in a lot of ways, this is why, in my opinion, VR sort of took a hiatus from the sort of consumer view after this time. The devices just weren't that fantastic, even though there was a lot put into them. Also around that time was 92-ish, this virtual fixtures that came out of the Armstrong Research Lab at the US Air Force. And this allowed military personnel to virtually control and guide machinery to perform tasks like training Air Force pilots. And it's really one of the first fully functional AR systems. It was very, very cool for its day. And then in 98, this may have been, for a lot of people, their first view of something that was AR-ish. 1998 was the first broadcast of the virtual 1st and 10 graphic in NFL football. So that might be the first time many of you saw something that we would call AR today. And then in 2010, things take a pretty significant change. So Palmer Luckey prototypes the Oculus Rift. It's got a better field of view. It's got a much faster processor. So the graphics are much better. And it really renews interest in commercial virtual reality. In 2012, he raises about $2.5 million through Kickstarter for the Oculus Rift. And then in just 2 years later, Facebook buys Oculus for $2 billion in 2014. So again, this really kind of marks, in my mind, the beginning of the modern era of extended reality in terms of development and investment and things of that nature. And following very, very quickly on the heels of Oculus Rift, there were things like the HTC Vive and the Google Glass and Microsoft's HoloLens and the Magic Leap for AR. And then in 2019, the Vario mixed reality headset. So enough about history lessons. How are these things used? So certainly you've seen from the history, there's been investment and certainly continued use of extended reality in the commercial entertainment market. So games. I'm not going to focus a whole lot there. I think partially because it hasn't maybe enjoyed the profound success that maybe investors had hoped for. Games like Pokemon Go certainly are great examples of where there were successes for those, but I think also for the audience, there's probably interest in other markets and use cases. And to that end, virtual reality, augmented reality, mixed reality, they are all in current use today within the Department of Defense for applications like pilot training, for example, certainly for weapons training, other high consequence training. And I think when you think about virtual and particularly mixed reality, training is a pretty profoundly compelling use case, particularly high consequence training. And again, this is training where you want to get users into an environment where they're gonna be perhaps using weapons or equipment or systems that could result in someone's injury or severe injury or even death. So great use case, right? Get that familiarity, get that understanding of how to perform those functions in an environment where you literally cannot get hurt. Outside of the training environments, there are operational use cases and successes. Certainly architectural, the ability to walk through buildings before they're built, to get an understanding of what a room layout is going to look like and what the view out particular windows is going to be like at different times of the year, and the ability to go see a building and get a tour of it before it's been built or even after it's been built if you need to get familiarity with it before you get there. Sighting is another operational use case that I think is super interesting, and the FAA is using virtual reality today to help understand how to place air traffic control towers before they're built. So you can easily imagine that where you locate that tower and how high you build it, and exactly what rotation you orient it in, are all going to have a very significant effect on how those air traffic controllers are going to be able to see runways, and how their view of parts of the space that they're controlling is going to change based on time of day and time of year and atmospheric effects and things of that nature. And then I would bet most of you are probably familiar with AR and VR being used in maintenance today. Certainly Volkswagen and Mercedes and BMW have all adopted augmented reality headsets to aid in the maintenance of vehicles. The ability to have, reference material come up in your field of view, and associated with particular components inside an engine bay, for example, really allows people to, do their jobs potentially faster, potentially more accurately, certainly follow procedures more at a higher rate of adherence. Manufacturing, another area where these technologies are being used. Certainly imagine, understanding, which wire to route in which direction when you're putting a wiring loom together is pretty good example. Another one that I was exposed to a couple of years ago was how augmented reality was being used in actually soldering printed circuit boards in a particular weapon system, and the manufacturer who had implemented this was telling us that the order in which the components were soldered and the manner in which they were soldered on the printed circuit boards was absolutely critical. And if it was done at all wrong, it resulted in the destruction of the board completely, and the boards cost $15,000 a piece. So for them, the investment to make into building an AR system to assist their manufacturing technologists with performing those functions had enormous ROI for them. And then many on this call, I would bet, are familiar with the Army's IVAS program and how it's leveraging the Microsoft HoloLens for some eventual deployment to dismounted soldiers. Then another area that extended reality is being used in that I think is particularly compelling is healthcare. It's certainly been used in pain management and continues to be. And we're actually going to talk a little bit more about that in just a bit. It's being used in mental health. I actually just saw an article in Forbes, I think a week or two ago, about an augmented reality application. No, I'm wondering if it was VR, but an extended reality application being used to treat addiction, which I thought was super interesting. Surgical planning, as you can imagine, when we talked about, that spatial understanding, when you think about, having to perform a surgery, particularly something as tricky as, resection of a brain tumor, it's really valuable for surgeons to be able to visualize the anatomy that they're going to be interacting with in 3D beforehand, in order to rehearse that surgery, so that they're not surprised when they get in there, so that they know exactly how they've got to navigate that anatomy in order to perform those functions. So healthcare, just to add just real quickly, healthcare I think is really one of the areas that this technology is going to be the most useful for in the future. So I want to talk about just a couple of really compelling examples. I'm just going to do two sort of quick ones here. And the reason I wanted to talk about compelling applications is, it's easy to think about identifying, the so-called killer app when you think about new technologies. And I think there's been a legitimate question around whether there has been a killer app or killer apps for these technologies. And I think from the consumer perspective, there probably hasn't been, but I would argue that in other markets, there are already many killer apps or killer applications of the technology. And first one I'm going to talk about a little bit is around pilot training. So I was lucky enough to be involved in a program called Pilot Training Next, that followed on the heels of about 20 years of myself and others trying to convince the Air Force that virtual reality would make a really good technology to help train pilots, and that was met with a lot of cynicism and skepticism, maybe is a better way to put that, for a number of years, until General Quast came along and said, you know what, we recognize that we have a global pilot shortage, and we also recognize that because of that shortage, there's a very high demand for pilots, and it takes a long time to train pilots. So we're going to start trying some new methods of training pilots to see if things work. And if they do work, we're going to adopt them. And if they don't work, we're going to toss them out and continue to charge on. And so this Pilot Training Next, I think it's about maybe 6 years ago now, was one of the first forays of kind of operationalizing virtual reality for pilot training in the Air Force. And anecdotally, the results were very, very favorable, right? So that first cadre of students that went through this program all got to solo within about 7 weeks, whereas using the historically traditional methods of pilot training, it would take them about 12 weeks. So, again, anecdotally, very, very compelling information. And there were other things about that program that were different, other than just the adoption of the virtual reality and critically the access that the students had to the VR technology. But nonetheless, still some pretty profound results. So the other example that I want to talk about is maybe a little bit closer to my heart, and really the one that I would reference first when I talk about compelling examples of how this technology is used. And this is in the healthcare environment. So I'm going to talk about this application, came out of the HIT lab at the University of Human Interface Technology Lab at the University of Washington, called Snow World. This came out a number of years ago. This is not brand new by any means, but there was a question that Tom Furness and others at the HIT lab asked, which was, could virtual reality affect, in a positive way, patients' perception of pain? In other words, by using virtual reality, could you reduce someone's perception of pain. So they developed this application, and it was specific to a specific therapy, which was around treating burn victims. And without going into a super deep dive on that, with severe burns, the recoveries can be long. They can be extremely painful because there are things like debridement that need to happen, which is like removing dead tissue. So at times having to stretch tendons and ligaments that have been shrunk because of severe heat. And the traditional modality for treating that, those kinds of burns, was to give patients opiates as painkillers, and then perform these procedures for as long as the patient could tolerate the pain from them. So what they did with Snow World was they put the user on into a virtual reality headset. The patient actually had very, very little interaction with that virtual world. They were on what's called a rail ride. So they didn't control where they were going, but they could control where they're looking. And they're essentially on a rail being driven through this snowy environment that, you can imagine there are igloos and penguins and polar bears and things like that. And their interaction with them is just to chuck snowballs at them, right? Very simple interaction. It's had a really upbeat Paul Simon soundtrack. And what they found really significantly was that in some cases, patients' perception of pain during the treatment was less when they were in VR than it was when they were given opiates. So just want to let that sink in for a second. You're having something very painful done to you, and you could be in VR and experience less pain than if you had been given morphine. So pretty profound stuff. The image to the far right there is a comparison of two functional MRIs, which show activity in the brain, actually in a burn therapy, and the areas in the that are lighting up are pain receptors, and it's just showing the difference between a functional MRI using opiates and then just using virtual reality. So really, really pretty exciting stuff, in my opinion. So it's not all Mai Tais and Yahtzee. There are challenges to extended reality, and certainly the photo of these two guys on the screen should give you some idea of how we are challenged. One of the big challenges is cost, right? So the headsets themselves have a cost. Those costs have come down, and they'll probably continue to come down to some degree, but they're not insignificant. There's also costs of development, right? So you have to develop a three-dimensional environment, or at the very least, three-dimensional imagery. So in any case, there's going to be a development cost. And if it is a full real-time 3D interactive environment, you've got, a rendering engine, you've got lighting, you've got certainly 3D models that have to get built, that have to have collision and perhaps animation associated with them. You have to have some kind of control schema. You've got to have camera settings and FOV, and it's just not cheap. It is getting cheaper, and we'll talk a little bit about that when we look towards the future. But other challenges are human factors. So VR sickness is a real thing. It is not the same thing as motion sickness, but it is similar. And when you experience it, it feels very similar. Essentially, it's, your eyes are telling you that you're moving through an environment and doing, and being oriented in a particular way. And your inner ear is saying, no, that's actually not what's happening. And that conflict somewhere back in evolution, we decided as humans that we were going to decide that probably meant that we ate something bad and we should get it out of us really quickly by vomiting. So not a lot of fun. There are some really excellent ways to combat this through development, but it's a significant concern, and it remains a challenge. There's also the weight of the headset. If you're going to be looking at a use case where somebody's got to have a headset on for, 30, 40 minutes, 2 hours, 4 hours, the weight of that headset is going to have an effect on your neck muscles and your fatigue level. And then there's also like just plain physical interference. If I've got a headset that's got a great big battery pack on the back of my head, and I'm used to being in an environment where my head is supported by, the back of a chair or a seat in an aircraft, that's going to interfere with it. And it's going to be a consideration and perhaps a challenge in how I develop my systems, and perhaps a challenge in it being adopted. And then there's tech limitations, right? I mean, if the devices are untethered, you're going to have battery life considerations. If they are tethered, you're going to have considerations over how big that tether is and how far you can go. There's going to be issues around dynamic occlusion, and without nerding out on that subject, if you're in an augmented reality experience and you're watching things, move around in your 3D environment, so real things move around in your 3D environment, and you're having to have computer generated things move around in that 3D environment as well. There's this challenge of, how does the computer know what to draw in front of what? And it gets down to, some very, very skinny triangles and some hard math that has to be done very, very quickly. And it's just not, it's not an easy thing to overcome. We've also got tech limitations around, particularly for kind of our markets, around like EM signature, electromagnetic signature. By putting this headset on, am I going to be more visible perhaps to an enemy now than I want to be? And certainly cybersecurity as well. And I think that makes sense for any kind of compute platform. You've got to consider what happens if that platform becomes compromised in any way or the data gets messed with. And then the last challenge that I'll talk about is really ROI. And I don't mean this from the traditional sense. What I mean by ROI in this sense is, if you are expecting a user to take the time to, put a headset on and interact with, whether it's a fully immersive 3D environment or whether it's an augmented reality, data layer that's integrated into your perception of the real world, that user's got to get something out of that experience. And quite honestly, the value of what they get out of the experience has got to be greater than whatever the cost perception of theirs is to putting that headset on. So if I'm thinking about the cost of putting the headset on, and I may be limited in where I can go, I may be limited in, if it's a fully VR environment, I'm limited in understanding what's going on around me. So those are the kind of costs that you've got to consider and weigh against the benefits, right? So, if the benefits are that I can train more quickly, get a better understanding faster, see data, be able to make better informed decisions more quickly, those are the payoff. And I've got to be able to balance those two things. And so, at the end of the day, developers really need to keep a very, very close eye on what those benefits to the user are in comparison to what the costs are of wearing the devices or interacting with those technologies. So, what do I think the future holds? And again, this is a disclaimer. These are just Gardner Cogman's ideas about what the future holds for this stuff. And it comes from the perspective of having used these technologies since about 1995. And so, your mileage may vary. When I think about the future, I try to sort of chunk it into two spaces, right? The near term and the far term. And, certainly in the near term and the far term, I think there's going to be continued investment in the technologies. And I think that the technologies generally are going to continue to improve. And, why do I think that? Well, again, I go to those compelling use cases. When you think about things like, pilot training, or you think about things like the use of virtual reality in the healthcare space and some profound results around that, we're really just scratching the surface on what kinds of use cases we've experienced so far. So I think when those sort of small numbers of examples have successes that are as compelling as a couple that I mentioned today, I think that's more than enough to continue to drive investment into the technologies and the use cases and the applications. Now, on the hardware side, it's a little bit harder to maybe speculate on what we think things are going to look like. But I would say that the headsets are probably going to continue to get lighter. They're going to continue to get easier to use. The visuals are going to get better in terms of resolution and field of view. I think too, the devices are likely to begin to merge to where you don't have necessarily that distinct separation between virtual reality devices and augmented reality devices and mixed reality devices. And I think that it's not hard to imagine a future where the degree of immersion is something that's user defined. So I might be in a training environment where, I don't want any other distractions from the real world. And so I'm gonna turn that dial all the way up to, complete virtual reality. I can't see anything that's going on around me outside of that virtual environment. To other use cases where, no, I want to just be able to see some data overlaid on what it is that I'm working with. So maybe I'm dialing that hardware back to a more traditional sort of augmented reality sort of scenario or schema. And then on the application side, again, I think we've barely scratched the surface on what we can do with these technologies. I think certainly when you look at how you can manipulate the human brain just through some hardware and a real-time 3D environment, there's big opportunity for continued development of applications that are going to be very, very compelling. And as I mentioned before, I think healthcare is certainly one of the leaders in that space. I think education is probably the other. When you think about the challenges of educating, and to some degree you can apply that to training as well. One of the common challenges is how easily or how effectively you can hold a user's attention. And one of the beauties of virtual reality is that if I've got you in VR, I control all of your distractions. I can create environments where there's not a window for you to look out of, where there's not your buddy in the next seat over who you're tempted to chat with. Certainly you're not going to be able to see your cell phone to see who maybe just texted you. So that's one example of how I think you could use extended reality in the education field to really change how effective our education and training systems are. But with that, I think I'll wrap up and see if we've got any questions. I want to thank everybody for your attention. Certainly my honor to be here and talk with you today, and happy to try to answer any questions you may have.
Thanks, Gardner. That was a great presentation. We've got questions coming in here. Remember, you can type in questions in the question box on the right side of your screen. We'll try to get through as many as we can. What do you think VR for military applications will look like in 2050? What big advancements are coming down the pipeline that make you excited?
That's a great question. I mean, I guess I could answer it in a couple of ways. I think that if we fast forward to 2050, I mean, the technologies are going to be at least as ubiquitous as your smartphone is today. So I think that they're going to be lighter weight. They're going to be more accessible and more easy to use and more easy to get into and out of than they are today. I think also, particularly in defense, you can't talk about anything today without talking about AI and the impact that AI will have on other technologies. I think is going to be that much more acute and visible in 2050, right? So one of the really interesting things is that traditionally the cost of developing interactive environments and immersive environments has been fairly high. We talked a little bit about that, but AI is more and more being used not just to write me a snippet of code that does this in C++, but I can just tell the technology what I want to see and then make adjustments to it. So, when you think about training environments, you think about other equipment perhaps that you want to be able to use in that training environment. I think AI is going to have an enormous impact on extended reality very specifically. And then you can go into the sort of the traditional uses of AI around trying to drive adversary decisions and movements and engagements. And that will obviously be integrated into XR as well.
And then we'll get to the Star Trek episode where they fought the whole war in the VR environment, right? Okay, how long does it take to actually build a VR environment? How quickly can developers react to consumer requirements? What does the development timeline look like?
So that's like answering how long is the coast of California, right? So you can develop a virtual environment very quickly and very inexpensively. The tools that are available today, that are available through like the Unreal Engine and the Unity engine, make things far easier than when I embarrassingly got involved in this technology a long time ago. So you can have an immersive environment built in as little as, I'm going to say, a couple of days for low bucks, and it's going to look like it was developed for low bucks in a couple of days. Large sprawling environments are obviously going to take longer, and certainly when you think about we're involved in updating. I think most of us on this call have at least experienced having to interact with image generators for things like flight simulation and training, and that you need to go update a map someplace and you're looking at months and months just to update a map, not even creating the map from scratch. So difficult question to answer, can be quick, can take forever, and everything in between. Sorry, I don't have a better answer than that.
So along the lines of that speed to use kind of question, are there any concerns with transitioning the XR training experience for some of those mission areas, flight, medical, manufacturing, to the real world? What have you run into as challenges? How are we addressing those challenges?
Yeah, so that's actually a really great question. So I think one of the risks is that you get something wrong in the virtual environment, in the creation of the virtual environment, and then it becomes what they call negative training, right? So now I've trained somebody to do something that's not accurate to how it must be done in the real world, and so that's a very significant concern that developers need to pay a lot of attention to. And so oftentimes what you'll see is the first sort of forays into this space tend to be things like procedural training, this is the order in which I'm going to do my pre-flight checklist, and this is where I need to go and how I need to perform that checklist. And things like eye tracking that are being integrated into the headsets definitely help that. I think that's one example of a risk where it can go wrong. Another risk is certainly in mixed reality. I've seen examples of a lever that needs to be pulled in a vehicle in a particular way in a particular scenario, and the first draft of that hardware was such that it took about a Newton of force to move that lever, and in the real world it took about 10 Newtons. And so the fear was, now somebody's going to think that that's broken, and they're going to be afraid to pull it as hard as you need to pull it, right? So that's another kind of example. And then I think the last one that's maybe a little bit out there for folks is there are ethics that you need to consider in this. And so if someone was to approach me and say, could you use virtual reality for interrogating a prisoner, I would say yes, you can. And I think that that's a very slippery slope. So what images you put into someone's head, and how you put them there, I think are a very legitimate concern. And I've not seen a lot published on that. But I think it's something that we all need to think about, because it's going to be coming.
So when you talk, mostly we've been talking about vision. Um, and so can you talk a little bit about how we're doing in simulating the other senses? Sound, smell, tactile, whatever.
Sure. So we don't have smell-o-vision yet, which is too bad. Um, Interestingly, we did look at one point around, smell's hard to do because it stays with the environment. I know that they were doing some stuff at Full Sail, that I won't reference who was doing it because I think that's still trade secret, but they were using smell in conjunction with virtual reality for a particular kind of training. I think that the interesting thing about that space is, we don't really have, this is all sort of, it gets sort of associated with the matrix, the extended reality technologies do. And, the big difference between the matrix and what's real today in XR was that in the matrix, there was a feed that went into the back of your head, and that could stimulate all of your senses. Um, do I think that we're going to get there? I don't think in my lifetime we're going to get that far ahead, but we are going to get to where there are other stimuli that are going to make things more immersive. That the question, I think, is, what's the ROI for those things? You know, some of the work we did around smell, and we actually used taste as a stand-in for smell, because taste is pretty easy to do, and it goes away, and smells hard because it stays with the environment. But we actually had Jelly Belly make some jelly beans for us that were basically cordite. So you could effectively smell exploded ordnance by eating a jelly bean, which was really kind of fun. Did it add anything to the experience? I think that there are some use cases out there where, certainly some of the work I've done in the past around, doing some rapid investigation, first responder type stuff for terrorist attacks. It's really good to know what kind of explosive went off, because it gives you an opportunity to understand what may be coming next. There's use cases out there for everything, and I think just at the end of the day, it's going to boil down to ROI.
Okay, we got to go into speed round a little bit here.
Okay.
And sorry, the first one's hard to do that with, but on this issue of integrating different senses, how do you develop something which tries to integrate sound and vision together? How do you pair those two different things?
Sound and vision together? Yeah, so most of the 3D tools that I've used in my career, they automatically have those two things, right? So the vision piece is going to be provided by the headset, and then a 3D audio engine, which is typically integrated into something like Unreal or Unity. It's going to come with the package, so you've got those development tools available to you. I wouldn't say that's particularly challenging today. I think that when you start expanding beyond into sort of more tactile things, it becomes much harder. So we've done things like, way back in the day, things like, vests that one could wear that, would provide some feedback to you that you had been hit by something. So this was really good in the early days of, for example, training SWAT teams to know when you actually are in cover and when you're not, because if you're not actually in cover, you can be hit. And certainly that tactile feedback can be a powerful way to learn, let's say. Those are, the tactile side, I'd say there are still investments being made. It's still coming along. it is not, it is harder to do, and it is not done as well as the vision and the audio piece, for sure.
Okay, last question. How competitive is the US in this technology area compared to allies and adversaries, both on the innovation side and on the manufacturing of product side?
That's a great question, and it's probably a good news question. So I think that I think in terms of developing the hardware, we're not cutting edge. I think that I think other countries, Finland certainly for sure is ahead of us in terms of mixed reality headsets, for sure. Augmented reality headsets, you know, we've got a pretty good game in that space. A couple of different companies doing it. Virtual reality, I'd say we're not leading the way. I think on the application side, we do better than anybody else in the world, without question. I have yet to see an extended reality application developed overseas that that remotely holds a candle to what we develop internally to the US.
All right, that is a good news story. With that, I want to thank you, Gardner, for the great presentation. Thank everyone for all their questions. I want to talk about what's coming up next for NDIA and ETI. First, you know, for the Tech 101 series, if there are topics you'd like to see us cover in the future, please email us at eti@ndia.org. Our next event is actually tomorrow at MITRE's Tyson's Corner location. It's on leveraging AI for acquisition. We're doing that tomorrow all day, 8 to 4 p.m. The NDIA events webpage has the registration information. The next Tech 101 in November is on contested logistics. Be on the lookout on the NDIA's website's calendar of events for more information and registration information. And then, given that we've been talking about extended reality, I just want to remind everyone that ITSIC, the large modeling and simulation conference run by our sister organization, the National Training and Simulation Association, is being held in Orlando, Florida, December 2nd through 6th, 2024. To see real-life examples of all these technologies that Gardner's been talking about, you should head down to Orlando. With that, I just want to remind everyone, always be on the lookout to the ndia.org/events website to see all the things coming up for NDIA. Thank Gardner once again for the great presentation, and thanks everyone for joining us today.